All right, welcome everyone to Robot Builders Night Virtual for June 30th, 2026. And we've got the usual a queue and then of topics that people are updating on, and then we'll throw it open to open mic. Let's see, is there any DPIG news that we want to share before we get going?
Well, we have the work day tomorrow, and then we have Moon Day coming up in a couple of weeks. We've got a good crew set up for that. Yeah, that's all I can think of actually. And then of course the next monthly meeting will be a swap meet and greet, show and tell, all the fun with pizza. So,
all right.
Can't think of anything else.
I can't think of anything else.
Yeah.
All right.
All right.
Well, Ray had something to share.
This will be very quick. So I showed a video, I think probably 2 weeks ago, with an older platform with, different motors and pretty much the same electronics that I'm moving over to a mower. And so this has an ESP32 with LoRa, a RoboClaw 2x30 motor driver controller. It's got an OLED display on it. This new one has the I'm calling them Husqvarna motors and wheels on it, whereas the other one had they were Tanner motors that I've had for a long time. Anyway, so I wanted to try. I had demonstrated in the video like 2 weeks ago, radio controlled mode and autonomous mode, and that worked for that platform. I just got out there with my wife to try to get autonomous mode working, and it refused to cooperate. So I have a 15-second video of it being controlled by RC mode. So like I said, it was going to be short. So anyway, so that's the mower with the Husqvarna motors and wheels on it, and the other electronics that I had on the other platform. So if I hit this, blink. Oh, okay. I don't know if you can hear it. It just makes little whiny noises.
It moves.
It moves. It's alive.
You're not even pushing it.
Anyway.
And is it cutting grass as well?
No, I have the motor off because you can't hear anything with the motor on. So, anyway, it doesn't. The motor, I thought maybe it's got basically a magneto generates the spark, and I thought maybe that would interfere with things, but so far it doesn't. It hasn't done that. So,
well, so it's a gas mower.
Yeah, it's a gas engine on it's just a little 20-inch. You used to be able to get them for, I don't know, maybe $120. Now they're like $250. It's amazing how it's like, wait a minute, what's going on with the pricing here? So, but yeah,
so
just
you put your own drive on the back and put casters on the front.
Yeah, casters on the front. The two, Husqvarna mower motors and wheels that we got from Sensori. And yeah, those are in the back there. I don't know if you can, if you can see them or not, but they're the wider wheels.
Oh, wow. So, cool. Cool. I love it.
Anyway, so that's as far as I got.
That's a gold star, isn't it?
Yeah.
Yeah.
Well,
saw something moving.
It's teleop though, and I was corrected in my hope of getting a gold star when I showed teleop. So we've got to be consistent here.
Okay.
Yeah. Maybe only a black star. I don't know. I'll
It's
let
a
you
black star.
Maybe we should do a silver star for like. Okay, no. Good job, Ray.
Silver Star in the Special Olympics, right? No, yeah. But anyway, yeah. So it's coming along. I don't know why it wouldn't cooperate with autonomous mode, but it was supposed to do the same thing. Move forward, pivot on one wheel, come back, pivot on the other wheel, move forward, and it just sat there. So
just once again, you've got the motors and wheels from Sensory, and and then a motor driver and ESP32.
Right. Yeah. And the ES2, that version of the ESP32, it's a TT Go version, and it has a LoRa transceiver on it. And I don't have the little box with me, but I have a little box that has 2 joysticks on it and a switch. And if the switch is in, one position, it tells it to pay attention to whatever it's receiving through LoRa. And if there's nothing being received, it's in autonomous mode. So I wanted that so I could, basically turn it on and maybe grab control of it versus, if it's going to, in my case, if it goes off in the weeds, I have a lot of weeds. So,
Surely that would never happen.
Oh, no.
Never happened to me.
So anyway, I just wanted to test it to see, it's kind of hard to say, I could get like a spring scale and pull it to try to, make an estimate of how much torque it would take to actually push the thing along. But, it takes a lot less time to throw it together and say, okay, let's see if it'll go. And either it does it or it doesn't, so. And the motors don't draw much current at all. Maybe like a third of an amp or so, which, so they have, just about the right speed, maybe a little on the slow side, but the batteries were like 22 volts, not 24 volts. So I don't know if I lost a little headroom there with, the batteries being just a little bit on the low side. So, but the RoboClad has a lot of protections in it, which can be a real pain in the butt sometimes, because when your batteries get low, like if you have a pretty conservative cutoff and you're doing things and all of a sudden you go to turn it on, it won't turn on. It's got a little red light on it that says, your batteries are too low, I'm protecting them, so it's like, So anyway, so.
Well, cool.
Yeah.
Thanks, Ray.
So that's the gasoline variant of, the gasoline non-ROS variant, I guess,
Gasoline non-ROS. Not quite autonomous yet, Mower.
That's right. Yeah, not still teleop mode, but So.
Hey, you'll get there. All right. Mike, you're outdoor robot.
Yeah, so I've been dusting it off and refurbishing it, rebuilding it with the electronics inside the cabin. And so the first thing, of course, was to and the upgrade on the power subsystem. But the first thing was to see if it all compiles and runs. And I stumbled at it, but I did something stupid, and then I got it all compiling and running. So everything's working. So that's good. So
yours was like a truck, right?
The what?
It was like an old SUV kind of thing, or was it a pickup?
It was a Jeep. Yeah.
Jeep.
Yeah.
Okay. Yeah.
Yeah. So I'll share my pictures and stuff just for fun. Let's see.
Mine is an RV.
Yeah. Yeah. So my to-do last year in my GitHub README was put electronics in the cabin and mount the LiDAR on the roof. And does the camera detect cones through the existing windshield?
Does it have a windshield?
Yeah. Yeah. So I sort of put the camera up there to look, and it was just horrible. And then I realized they put a film on it, like a tinted film, and the film was just, well, no, it was pretty dirty looking. I know it wasn't dirty, but it just sort of made a real bad image. So I took the film off, and I think it might be okay. If not, I have to cut a hole in the windshield and put a more clear polycarbonate in there. Okay, and then the other thing is improve the external DC power, and then I need to get some mechanics. I need to work on the transmission and the drive chain. Yeah, because I noticed there was noticeable grease and oil underneath of it last time. so it's losing some grease and oil, so I got to take it apart and work on the transmission, I think.
So the thing actually has a drive chain, or did you mean drive train?
Train, I guess. Yeah.
Oh, okay.
Yeah, train. Yeah. I was looking. I seen there's a lot of misspells in here. So yeah.
Camaria.
And then the code, basically, I got some code work to do. And then I'm going to try to get a simulation model. That's a lot of work. Maybe don't want to convert to RTK. Takes a lot of money, but I've been noticing that some people are trying to do it with less money, so that's not bad. Oh well, so this is what I did. So that was my laundry list last year when I put it away. So this is the chassis without the electronics. It's all been pulled off, and that's the top right there, and that's the LiDAR. So I just wanted to show, okay, this is the chassis, and all these wires have to hook up to the motor controller and batteries and put it all back together. And this is underneath of the cabin. So I have a wood platform, and all the wires hook up to this is my motor controller that goes under the hood with a battery on it. And they hook up to the electronics inside to this hole. All the wires come down here. And there's a USB coming down to the motor controller. Okay, yeah, I'll just go. So this is like what it looks like with the, it's not on the chassis, it's just on, I just mounted it and it looked like that. So that's what it should look like. And this is the electronics, like sort of on the front view here. So I have the speaker, and I have the camera here, a USB hub over here, power subsystem here, the Pi is back here, and I have a little platform for the GPS and the IMU. And this is sort of the back end here where you can still see the Pi and this is the controller for the time of flight sensors on the front and back bumpers. That's a big thing I need to do next, is mount the time of flight sensors onto the bumpers of the chassis of the body of the car. And so you can, then I have a Wi-Fi module here and some Wi-Fi antenna right here. So it should have good reception to Wi-Fi. And this is sort of the back. I thought it was pretty cool, but it didn't picture. You can see all the little lights flashing and stuff on the inside. In the side view, same thing. It looks cooler in person. So that's my little one of my little show and tell. I'm going to stop sharing this, and I'm going to share the Rviz. Where's my Rviz? Rviz is. So it's sitting downstairs on the first floor. I'm up on the third floor now. So, and it shows the LiDAR seeing the room. The body of is blocking it from seeing in the down direction here. And then you can, these other little dots here are the time of flight sensors seeing stuff. And here is the camera. There's nothing to see, but the camera is over here. So the camera's active. Sometimes it sees phantom cones. So it looks like everything
is the LiDAR the red trace?
What's that?
Is the LiDAR the red trace?
Yes, it's the red trace.
So then how come the time of flight, is the calibration off? Because the time of flight sensors are seeing further out than the LiDAR.
Oh, well, the time of flight sensors are sort of dangling on a cord.
Oh,
okay.
Okay.
But they're not mounted to align with anything.
Okay.
That's my big thing, is to mount the time of flight sensors on the body of the Jeep so that it has a good orientation.
Yeah.
So that's sort of why it sees weird stuff. And I think I have it backwards too. So this should line up with this over here.
Oh, okay.
Because I flipped around. I think I flipped around the LiDAR
That
to
makes sense.
Yeah. And then this line here is sort of this, but crooked. So yeah. And this is like a chair, there's a chair in front of it. So, but the LiDAR is backwards, so that's the problem. I got to go in and change the orientation in the what's that file called? It's called the what's that file called? Crap. Oh, this isn't the file. Okay. Oh well, it's just a file change, because right now I have it looking backwards, and oh well. So I just mounted it the way the manufacturer recommended it. I didn't realize why before, but now I do. And the reason they mount the RP LiDAR quote backwards with the cable facing front instead of the back is so that when it's scanning on the forward direction, it doesn't have the seam between end of scan and start of scan. So the LiDAR has a little mark on it, an arrow, and that's sort of 0, and basically 0 to 360. And when it's moving, you get the distortion, and you get a big discontinuity right in front of you. So the manufacturer or the people recommended mounting it backwards.
That's a good idea.
And using the URDF to just rotate it at 180 degrees. So
that's a great idea.
So I found out that's why, because now in the front there's no seam, so it doesn't distort as much. So that's sort of my show and tell. It's just showing you that, you know, it's coming back to life, and I just have to do a good mechanical build, and I'm getting there. Yeah.
Nice. I like that. I like that platform, Mike. That's a really, really good looking platform, and nice to see a wooden base with all the electronics mounted on it.
Yeah, spread it all out.
Yeah.
Oh,
I
I did
love
one
that.
more thing I could share. Wait a second.
Someone-
One more thing. Where is it? It's
So the seam on the LiDAR that you're talking about, is it like a support post, opaque post or something in front of the LiDAR?
no, it's just when the LiDAR rotates, there's a 0 degree, and then it rotates all the way around to 360.
359 or yeah.
It's a time delay.
And so that means that there's a long delay between the data, like 1/10 of a second between 1 degree, 1 pixel
Oh,
off,
yeah.
1 pixel to the end. And
Yeah.
so if it's moving and if the whole body is rotating, then that
Oh,
causes a big discontinuity.
Okay.
Yeah, yeah,
But isn't that
'cause the
true
whole-
for any point on the LiDAR surface?
Pardon?
Isn't that true for any point on the LiDAR sweep?
No, I
At
think
any
the
point in
first
time,
one,
you could
right?
pick an arbitrary LiDAR sweep, and by the time you get back around to it, it's exactly the same amount of age old.
But that's the longest age, right? From 0 to 359. Because if you're talking
Yeah,
about
but
adjacent
it
ones, that
doesn't
could be
matter
really-
where you start. It's always going to be the same delay at any arbitrary angle you choose.
Oh, I'm not talking about the delay. I'm talking about when it creates an image, like,
Right.
and it sees something, it'll be like this. But if your body moves and the 0 and 360 seam is in the front, you'll have an offset like that.
Right.
So it goes around, and instead of lining up with the other degree, it's offset quite a bit. And if you rotate it backwards, then
Right.
you don't have that big discontinuity between those 2 pixels.
Yeah. Any 2 adjacent pixels
Right.
would be almost no delay versus
It has a few
0 and 359 is going to be a significant delay.
Yeah, it'd have a few milliseconds of delay.
Yeah.
That
Okay.
assumes that you're traveling in one preferred direction, which makes sense for your chassis.
Right. Yeah. So basically, the stuff in the back, it's just backup avoidance stuff. So it could have some discontinuities, but in the front, you want to be more precise. I was trying to find my.
And really, I mean, your point is good, Kareem, but really the bottom line is that all of the data, the whole scan's worth of data, gets one timestamp and gets like placed on Rviz as one scan. And so that's really the underlying problem. It's not that there isn't much of a time difference, as you say, between the end of one scan and the other, but it's that they're all bundled into different packets.
In the L2 driver that I've been working on with this other author, a third-party driver, we put a timestamp on every single point, and it is interpolated, so we know where it is in the sweep.
Okay,
That's a good idea.
I guess you're not doing anything like that.
Yeah, Ross can. Yeah, can try to smooth it out. Yeah. Well, I can't remember what I was going to do, so I'm finished.
So, Kareem, are you incorporating odometry with that as well to say, okay, I've moved so far forward in this scan between this pixel and the adjacent pixel or something?
So the way it works in RAWs is that, so you can do odometry just from LiDAR data if you want. It's not the typical way you do it in RAWs. In RAWs, you fuse multiple sensor inputs along to do something that's more like this. It's called localization. So it's a step above odometry. So the odometry for most robots still is based on what like in wheel encoders are telling you, plus an IMU, what that's telling you about your heading changes and pitch and roll, if that matters. And then you can fold in LiDAR data, but LiDAR data is it's not great for that. Vision is better at doing sort of vector fields and interpreting motion from that. But basically, you take multiple different kinds of data and fold them together into a localization solution that is not from a single odometry source. And the theory, and it often holds true, is that that's more resilient to sensors dropping out, variations in signal from your different sensors and such. So it's supposed to be a more robust approach. And then if you do LiDAR localization, it's usually against a mapped room. So you see where your current LiDAR is appearing relative to a map that you have from prior scans. And then it typically uses, there's a couple of different algorithms, but adaptive Monte Carlo localization is probably the most common to sort of fit what the live scan is seeing against that map of where the walls are. And so it also creates a sort of a fix for you, and that gets fused with all of your other sources to give you, again, a more up-to-date location. But it works different. So like I use that indoors, but outdoors I only use, I don't only use, but I mostly use RTK. I still have the odometry, I still have the IMU. I don't have an outdoor map that at least not yet from the LiDAR. I'm using the LiDAR outdoors to detect obstacles. And I'm starting to model the ground so that I can like get a little bit more sophisticated understanding. So I'm exploring this package called Ground Grid that gives you that tries to figure out where the ground plane is, and so you can get both positive and negative divergences from the ground plane and consider them obstacles. So a negative would be like you're on the edge of a road and there's a big drop off right there. It's the deep shoulder, and you want to consider that an obstacle so you don't drive off into it. Or you could have a log lying across the road, and for whatever reason your vision is looking in a different direction, so maybe you pick it up on the LiDAR. And so the thing I'm struggling with right now is that the LiDAR, the sort of the accuracy, the range accuracy on it or precision on it it's not as good as I was hoping. It's probably, I'm hoping to get it down to as low as like being able to detect a 5 centimeter tall obstacle. But right now I'm hovering at about a 10 centimeter tall obstacle, which my robot can still technically surmount. Like if there's a 2x4 lying in the way, it can climb over that, but you don't want to hit it at full speed. So it's much better to be able to detect obstacles lower to the ground than that. But otherwise, I want it to haul ass and go as fast as it possibly can, which is not fast. It's only like 1.5 meters per second.
It can still flip though. Yeah.
Well, mostly the flips are like falling downstairs. That's another negative obstacle to avoid.
Yeah. Voids.
You don't necessarily want to catch air with your robot, huh?
It hurts.
Yeah.
So
I've done it twice, and it's a 25 kilogram robot. It's like once it tumbles, it's gonna keep tumbling. I don't want to get in its way, so I've done it twice, and yeah, that was not a great experiment. I'm surprised that mostly it survived. I did have to rebend the arm to sort of it bent all of the brackets on the arm. And I've lost the elbow motor twice. That's the weakest link on my robot's arm.
I wonder if you can get robot insurance these days, you know.
You can get insurance for anything. So I'm probably priced out of that market though.
Yeah.
So Mike, you were talking about RTK GPS that you're thinking about, and expensive versus not so expensive, and so I just wanted to thought it'd be an appropriate time to show that I've mounted that LP29H on top of the Raspberry Pi.
I was showing something, sharing my screen.
Yeah, what is that resource?
Yeah, because I want to do this and then wrap it up. Yeah. So I'm running Ubuntu desktop on my Raspberry Pi, and I'm running Rviz on the Ubuntu desktop and using VNC to view the Rviz. And you can see that all 4 cores are running at 100%.
Yeah. That's where I am all day long. It's horrible.
Yeah. And I'm powering it with a lab supply, a 12-volt lab supply. And when everything's running, it draws about 2 amps from the 12 volts. So, so it's it draws a lot of power and runs all the CPUs at 100%. It's like, ooh, I need to figure out it.
The compute is drawing 2 amps, or the whole robot?
The whole robot, yeah, all the sensors. So I'm guessing that the computer, the CPU, the Pi is probably running about 1/3 of that, and then all the sensors and the spinning LiDAR and all that stuff is probably the other 2/3. The camera gets hot. It's a oak light. They run pretty hot, so they must run a lot of power. Like an amp, it's probably an amp of 5 volts just for that. So
yeah,
so that's
I'm pulling about 3 amps on my system.
12 volts.
At 12 volts, yeah.
Oh wow, yeah. Because I was wondering, to do all the stuff you're talking about, you need more CPU. So hopefully, you have something better.
I do have more CPU than a Raspberry Pi.
Okay.
Not much more. I need more. Need more.
But you can see here, like my memory is only running at like 4 gig out of 8 gigs, so that's pretty good. And I didn't have to use any
15 gig of memory, and that's not my primary bottleneck.
Yeah. Yeah. My Pi 4 had a memory bottleneck but this one doesn't, because I got it at 8 gig. So that's good. Okay, I'm gonna stop sharing. Yeah. So lots of power. Okay, thanks, Paul. Go ahead.
So, well, I was just going to offer that that I'd gotten the LC29H mounted on the Raspberry Pi, and just yesterday I figured out how to get the serial port. So it uses the UART0 serial port on the Raspberry Pi header, and for Ubuntu, there's 2 statements you need to add to the boot /config.txt file to turn off Bluetooth and to configure UART0 to use pins 8 and 10 in order to get the serial data from the LC29H out to the Raspberry Pi. So anyway, I'll document that, but I think I'm pretty much done with the driver. Need to update that one documentation item, but all the rest of the documentation is complete. So anyway, if for what it's worth, it's out there.
Yeah, because I'm anxious. Well, not anxious, but I'm looking forward to upgrading to RTK someday. But I should be able to find the cones and stuff with just regular GPS. It's probably be a little clunkier, but then maybe next year I'll go to RTK. But this year I just want to get everything running solid. So
yeah. Yeah, I think one of the things I realized was I had too much of a telephoto lens and really needed to go, or vice versa, a wide angle lens, and I really needed to narrow it down for the the field of view, like a telephoto lens for the outdoor contests. Otherwise, the cone is so small you can barely see it in the image because the image is so so broad.
So I think next up was me with a Moberry update. So the number of Moberries in my lab has doubled. Glad was over today, and we were trying to bring up his bring up his Moberry. It's wheel spin, but they do the herky jerky. They're like, and it runs the motor test program just fine. Forwards, back, one forwards, stop, one, the other one forwards. That works great. But under teleop, it's like super jerky, and then but anyway,
is that unique to his, or is that a common problem right now?
Well, it seemed we connected my motors to his controller, and they kind of, one wheel worked, but the other one didn't. The other one had the herky jerky, so it was not a clear answer out of that test. And I did find the grounding problem that might have been responsible for the demo flub that I had last week, where it sort of backed itself into a corner and wouldn't stop. And so I fixed that, but that didn't fix it. But so anyway, besides getting the RTK GPS mounted on the Raspberry Pi, I've been working on the motor controller. Has a 1,000 microfarad capacitor that gets charged up to motor voltage, 26 volts, and there's really a pretty healthy arc when you plug the power connector in together as it mates, and I mean, so much so that it welded itself to Vlad's power connector this evening, and so I've been working on a circuit to try and fix that, and I thought I'd share that, and so so I asked AI to how to suppress the surge, and it said, well, you really need a surge suppression circuit, and so this is what it printed me out, which seems like it would work. It's a P-channel FET, and you can imagine that if the input voltage is, for example, 8 volts or 10 volts, then during ramp up, which happens very quickly, obviously, this capacitor is going to be a short circuit. So effectively, you have 4 volts across here. So your gate to source voltage will be 4 volts. So then the FET is just starting to turn on, and so as this capacitor charges up, it slows the turn on of the transistor, and then this Zener diode limits the voltage at the gate to 12 volts, and you got 24 on the source. So it's fully turned on by the time the input has reached 12 volts. I should say has reached about 18 volts. And Paul Urbanus took a look at that and said, the capacitor's in the wrong place. And he did a SPICE simulation. And so we're getting real high tech on the Moberry project here. And why did that just disappear? I don't understand why it just disappeared. I know. Anyway, that was a slow ramp up, and reality is the input voltage ramps in microseconds. So, but he said, the capacitor is in the wrong place. This is a better circuit, and what happens here is the voltage in goes up like in microseconds, but that pulls through this capacitor, that pulls the gate up in microseconds. So essentially, the transistor remains turned off until this R2 starts charging or bleeding charge off of the lower end of the capacitor, which causes the gate voltage to ramp down and the transistor to more gently turn on. Ignore this diode; it's not effective in this circuit. And so, with increasing the capacitor value, we ended up with a slope like this blue line. So the yellow line is Vin ramping instantly in microseconds. The blue line is 20 milliseconds after input. The FET starts to charge up, and it takes about maybe 6 or 8 milliseconds, 6 milliseconds maybe, to ramp up to V out when the transistor is fully on. So so that was pretty interesting. And the voltage on the gate is shown here, and right when the voltage on the gate hits about 20 volts is when the transistor starts to turn on, and it's pretty much fully on by the time the gate is at 19 volts. So so anyway, that's been experiments in surge suppression. So I actually ordered some P-channel FETs and built up a little proto board with. You don't need. Turns out the diode does no good here. You know, it was a kind of like left in, but Paul didn't realize that what was there was a Zener. So anyway, I left this diode out. But so I tried it out, and there was no spark when I wired it up, but it was just a first test, and I want to stick a scope on it and watch the ramp when I connect V into it and capture that. But so anyway, that's a sort of interesting exercise I've been engaged in, and so as a part of that, I put the schematic into Easy EDA and figured out how to drive that and lay out a circuit board. So interesting stuff. Getting I figure I'll ship it off to JLPCB and get a board built. But meanwhile,
yeah, power subsystems are really important.
What's that?
The power subsystem is really important to get right.
Yeah.
It's one of those things. It's like it's just a battery. No.
You should see the arc this thing produces. I mean, it is something when you feed a battery directly into 1,000 microfarads.
Does your motor controller manage the back EMF from the motors?
I assume so. I actually don't know. That's a really good question. Yeah, what happens to it when you're talking about when you suddenly tell it to stop and the motors are spinning and you get some back EMF out of them?
Or if you turn off power real quick.
Yeah.
Yeah, it doesn't have a path to discharge it. I think Roboclaw, they recommended sticking a diode across your switch so it could still, the inductive kick still had a path back to the battery. And that works pretty good.
Oh.
Yeah, because it can buy your electronics. Yeah.
Yeah, it'll quickly, jump to a super high voltage. I think the Roboclaws are only good for like 34 volts. So if you go over that, you can fry it.
That's a real good idea.
Yeah. And I think, Mike, you looked at some other circuitry to take care of that too, right? Didn't you?
Yeah, yes, I did. Yeah, for the theatrical robot, and then I had a motor spinning a piece of art, and somehow all my electronics got fried. And I think during transport, the big picture frame hooked up to the motor got twisted, and it caused a little high voltage and fried everything. Because I put a protection diode in that, and so hopefully it doesn't happen again. Because it was during the gallery showing.
Well, I wonder if something like that is going on, because I fried two 3 amp DC to DC converters while plugging one died after about 3 days, and it just wouldn't output any 5 volts anymore. The other one went pop and let the magic smoke out the first time I connected it. But there's hardly any load on the 5 volts. It was really the big surge happened on the 26 volt.
Oh.
So I don't know if that would somehow
the voltage converters have a maximum input voltage, so yeah. The voltage regulator could have exceeded its max input voltage.
But how would, just while plugging it in, the motors weren't running, just plugging it in, how would that produce an inductive kick?
Yeah, that I don't know.
Don't know.
Yeah, I guess you'd have to look at the circuitry and the devices used and stuff.
Yeah, because my picture frame motor, it was hooked up to the 5 volt supply just directly. And then when I did a post smoke test, just looking at the circuit board where all the char marks were, the 3 volt regulator was gone, was just fried. It was outputting 5 volts. So, so of course the RP2040 was unhappy and dead. But some of the other electronics could handle 5 volts. So, yeah. But that big voltage surge destroyed the voltage regulator on the RP2040 board that converts the 5 volt to 3.3. And the weird thing is it worked for a couple of weeks, and the artist didn't complain to me, but after it's finally completely died, he said, "Yeah, I've been having trouble with it. I've had to restart it lots of times." So it looks like it got damaged and slowly got worse and worse until it just stopped moving at all.
You're out here having problems with lightning strikes. I don't think you can see it, but there's a little piece of the top of that integrated circuit missing. Blue smoke.
It's not in the frame, Ray. It's not in the frame.
Okay. How about there? Let's see. Okay, yeah, there's a little dark spot there.
Yeah. Oh, that's where the magic smoke blue escaped.
Yeah. Yeah. Yeah, I don't know. Switch mode. You probably wouldn't get those kind of failures with like a linear regulator, but linear regulators aren't very efficient. What goes on in a switch mode? I mean, there can be lots of weird things. I think even if you're trying to power an inductive load, and the current changes on that load quite a bit, you can get, basically kickback or, the collapsing field or spike from inductance or a good sized inductor if there's one in the line or something. So, and these little cheap converters, I don't know that they use the best components in them anyway. I think it's You know, I usually go for the lowest price, so I think you get what you pay for. And but some of them have been pretty good, especially the ones with the little displays on it. Those are kind of nice. You can just look at it, and it's got a little LCD display, so it draws very little power, and you can look at input voltage, output voltage. I think the one that I have even shows output current.
Nice.
But yeah, those are nice. But
Yeah, that is nice. I went with a waterproof one, so it's all completely, you know, just a block, an epoxy block, because I wanted to mount it outside on the mower, you know, separate from the electronics. Anyway, that's all I had. Does anyone else have anything? Doug?
Yeah, I have a follow-up from last week. Okay, so let me show you. I don't know.
yeah, there's a 5-volt buck with a display on it, and it's kind of nice.
I think that's kind of where we go.
You got your encoders in.
Yeah. So here's what the encoder looks like completed. And this is a TPU cap that I can just slide right on. Here's another set that for the other motor. So this is what you start with right here.
Yep.
And I've knocked off the little thing. And like I said, acetone's your friend on that one. So question Kareem asked was, you know, what does it look like on a scope? Now this is a single trace, so I'll turn it on and we can watch it. There's a little jitter, but that's almost perfect 90 degrees right there.
Yeah.
So, which is what I kind of expected. So I found out a few things about these motors. They're, okay, the 24-volt motors, if you consider these 24-volt motors, they have a speed of 330 RPM. The gearbox looks like it's a 12.7. Okay. This encoder
did 70 to 1.
Yeah.
This one?
Yeah.
No, I don't think so.
It is.
Yeah, I think so.
That would be really fast, Doug.
Yeah, it would.
Given the wheel diameter.
Yeah.
Okay.
You're talking about output shaft.
Well, let me flip it on. Maybe I made a cap thing. All right, let's see. Okay, so you can see it's barely crawling right now.
Right.
Okay, show. So right now it says it's doing about 300 pulses per second. And it's just very crawling here. Okay, if I put this on normal. Okay.
I thought you said RPMs.
I did. So anyway, so let me get this going. Okay, so here's what it's looking like live. Now you notice here, this is where it's being triggered. So it's jittering, but it's still maintaining the 90. Now I'm gonna crank the sucker up to 20. Well, let's start 15. And I probably did not comp out my pulses. I comp out my leads, so there's probably not as clear as it could be, but you still see it's doing really well. And I'm looking at that as about 223. And then if I flip this up to 24 volts, here's 24 volts. Okay. And like I'm thinking, if I did my calcs right, it was about 326 RPM.
That looks awfully slow for that.
That is not 326 RPM. Something went wrong.
That's probably right. You're right. Okay, so I got a
There's
calculation.
no way.
Now on the back, you can see the dude is spinning quite fast.
Yep.
I'll have to see where I did the calculations. But it's so okay. Let's do. You say it's 70 to 1.
Yeah.
Okay.
Yeah.
So let me do the calculator. All right. So I have about 4,150. Say. Four, one.
Yeah, because it looks like you're making a rev under a second, a little under a second, right?
I'd have to. I do have. Well, let me pull. I don't know if I can get it to work in this light. You can see what we got. I have one. I have a marker on one of them.
Which would be more like less than 60.
Might be a little over 60.
Yeah, revolutions. Yeah, because it's a little under a second. Yeah.
Yeah. At 24 volts with no load, I measured the output rotating at 60 RPM. So one revolution per second.
At what
Yeah.
voltage?
At 24 volts with no load.
All right. Well, I'll have to check that out. It does that looks about right. I wouldn't be. I think you're right, Paul. I'll have to check where I made the mistake. Yeah.
And then
But anyway, so the question is, if the encoders work, they work very well. They maintain quadrature almost perfectly, and they all through the range, all the way up to 30 volts. You know, I pushed them a little bit. That's
All you
30.
need now is a hair dryer and see if they do well under temperature. Just so
Well, under no load, they don't get very hot. But
no, they should do.
this is ASA. This is ASA, and this is TPU, and I think the original was ABS. So they should do better than what was originally there.
Oh, one of the things that I wanted to add before I forget, the motor diameter, it fits in the GoBuilda. It's basically the same size as the GoBuilda motors. So you can use the structure elements from GoBuilda, to make a cage or a frame for the motor to mount it on something. So that can be kind of handy.
You mean
the U channel?
you're talking about this part?
No, the body of the motor.
Yes.
Yeah, that diameter fits in the GoBuilda U channel. It's the right diameter.
Okay.
But if you make the encoder too big, it won't fit.
Yeah, the way this one works, you just put this in here,
It is very close.
and I guess I got it backwards. Okay, I don't know about that. This could be put on later until you start soldering things in. You can see there's two leads that you have to solder into it.
Yep.
This is what it looks like. This is what you're soldering into.
I tried to find that on AliExpress and didn't have your link. Could you have a link for that again?
I put it in last week. It should be in the notes.
Oh, okay.
Okay, so I have to look around for it now. I don't.
Okay. All right.
Yeah.
Thought maybe you had it handy.
I could give you the Amazon link real quick.
Okay, Amazon's fine.
Yeah, I mean,
Anyway, the first run of going outside, the only thing I could think of to hold the motors in place, I made kind of a U channel out of stamped steel pieces and used a hose clamp to try to hold it in. And the first run, I only used one hose clamp per motor, and the motors have sufficient torque to twist that around, even though it was tight. So I figured, okay, double the hose clamps, and now it's staying in place. It's not, the motors are not twisting around in my mount.
Well, I can tell you, at 20, even when I make it crawl, you're not going to stop it. You know what I mean?
Yeah.
Torque.
Yep.
So let me see your chat. Alright. All right, I put the Amazon. And,
Thank you.
and then let me,
Great.
the name of it is, let me write it down so I can remember it. If you look at the Amazon line, it's CHANCS, but the link on the internet is that with motor on it.
Okay.
And it is calm, I think. Yeah. And then you have to go to products and encoder. And I think this is the one I got. Here's another link to it.
So why has it got 6 wires, Doug?
4 for the
Why is it got-
encoder and 2 for the power. I actually split this up. I split it up to separate the power from the 4 encoder ones.
Well, is it 2 motor leads plus VCC ground and then 2 encoder outputs?
Yeah, let's see if I can find where they talk about it. Different, they have somewhere, I found it. They have maybe it's on the specification. You have to look at the one that I showed you. I think goes like 5 to 25 volts. So, potentially you could use the same one, but the other one is only 5 volts. So you'd have to make sure the one that you had, to run it safely, I would have it on a 5-volt supply, separate from the motor.
Oh.
So for the 4, you have, ground and encoder VCC and A and B. And then you have the other 2, which are motor power. And that's pretty much it. I can say I hit the single mode. Looks real good even at high speed. Whatever speed this is. Yeah, this is high speed. So anyway, that's good. I'll have to find my little program error, but other than that,
Did you say which motor driver you're using?
on this one, I just got it hooked up to a power supply.
Oh,
Like
Yeah,
a lab.
it's just- It's putting out low load at 30. I'll put it at 24 volts. So we put it at 24 volts.
Probably 200 milliamps or something.
And it looks like, yeah, about 200 milliamps, I think. It's not pulling much load on the power supply. Now that's no load. You're not going to stop it. Your hands. So anyway, the question is, these encoders, like I told you, I like those ones where there are 2 integrated together because the spacing, as long as you use the same magnet, the spacing is almost guaranteed to work. So That's
Mhm.
I like that a lot.
yeah, and the spacing. I don't know if I can show you. I'm gonna stop the motor. You can see it's pretty close. I don't know if I can get. Can you guys? I don't know if I can get it in focus.
Yeah, that's
Here's
important.
So here's the sensor, and you can see the magnet is right in on it, just almost touching, but it's not touching, and definitely not touching. So
Hmm.
pretty cool. And I'll be quite honest, I'd be really interested to know, since I'm just using a slip fit, a slip fit onto the shaft. Yeah, it looks like I got it on straight, but if I were off just if I had it cocked like that, for example, that's an extreme. It would might cause some of that, a little bit of that jitter, as opposed to getting it really locked in. So if anybody wants these files, I can put them out there somewhere. For that and the rubber cap, plastic cap. But they're not very complicated. And there's only one. The fit of the motor diameter will be somewhat dependent upon your printer. I mean, if you want a snug fit, you know what I mean? Yeah, I'm thinking, I'd like to use this part of it. It's such a nice snap-in type design.
Yeah.
And I'm curious, I haven't actually looked at the mower part to see if that's, maybe me and my angle grinder, you might be able,
those ears off.
yeah, I might figure out how to get that on there.
Yeah.
But then again, I might even use their base if I go that way. But I am happy with the fact now that I have an encoder solution for their motors that I feel much more comfortable with theirs, because I want to show you. I'm not trying to knock anybody here, okay? So,
But
no. You unscrew what was on there before. Look at that, where that sensor, how that sensor is bent back and just kind of there. And and this one's better. It's almost straight up and down.
yeah.
I didn't actually test their encoder, so I don't know how well it worked, but I don't think this one would have worked very well. So
Yeah, it's hard to say what the state of them we're left in, maybe chucked in a drawer or something.
Thrown in boxes over and over and over again.
The price was definitely right though.
Oh yeah.
Yeah. So free.
So I got a question for you guys. What would you advise me about the considerations for and against? So I've doctored the firmware so it can handle the single channel encoder of the sensory motors, and I've got a pile of them. What do you think the consideration? And I've built up 2 wiring harnesses now, which I need to add a wire to them to accommodate the extra wire. But what do you guys think would be the pros, the advantages, if I were to, like, significant advantages for a mowing application, if I were to go with this Quadrature solution, 12 counts per revolution versus 1 in the original design?
Hmm.
Well, these have 16 pulses per revolution, or 16 pulses for total revolution.
More accurate, but I'm trying to weigh the benefits, because in a mowing application, your slippage on the grass is going to sort of like swamp the increase in accuracy.
Yeah, you'd probably use these for speed control.
I-
You know what I'm saying?
To me, the biggest advantage is if you're, excuse me, trying to make angular corrections, like if you're using GPS RTK to figure out what your heading is. At 70, you know, 70 pulses per revolution, you know, it's going to be a much coarser adjustment, you know, versus, well, I guess in my case, I have the 20 count. So that gives me 1400 pulses per revolution at the wheel. So I can make very fine adjustments for basically if I'm trying to do angular corrections, like if my heading is off just a few degrees, you know, it's a much finer adjustment than 70 per revolution.
Oh.
If you're using RTK, I don't think it makes any difference.
What?
What I'm trying to say is, do you even need encoders if you're using RTK? So,
Yeah.
You need encoders when the GPS goes down.
okay, now that's a good point.
Yeah.
And so if you needed encoders at all, then would you rather have good encoders or
Bad encoders.
so
Yeah.
that's you do, so I guess that's kind of the question you got to ask there, Paul. You know,
Yeah.
to me, for $15, this is a no-brainer. And I mean, 2 pieces of 3D printed plastic. You know,
Got yourself a really nice mower motor there. Huh?
yeah, and if I use it somewhere else, I'm not saying I would, but you know, if for some reason it would, you know, it'd be great.
Okay.
I mean, it is now with this encoder in it, this motor is good as any other motor that I could buy with its
Okay.
torque and whatever. Okay. So it just depends on,
Yeah.
yeah, if you got to depend on encoders, you know, like I said, you want a good encoder, you want a bad encoder.
I think the David Anderson rule applies. More counts are better. Get the most counts you can get. So
Yeah.
So, well,
On the
thanks.
other hand, it probably is not going to add a whole lot to your situation. Right. You can just assume it's that the wheel is spinning in the direction that you're telling it to. So you don't really, you're not that sensitive to back pressure and stuff like that because of the amount of torque you got and the fact the slip is going to be
Yeah. How does
the first thing to go.
Yeah. How does the mower handle obstacles? Does it like stop, rotate, and turn, or does it go backwards, stop, rotate, and turn, or does it see it so far ahead that it's like Dave's where it would just kind of like mosey around it? I mean, what does it do when it has obstacles? You know,
I don't have an answer to that relates to Moberry, to the planned mower.
Yeah.
And the answer for the original mower isn't really relevant. It just hits something and backs and turns. But it's,
Yeah.
you know, that's how it doesn't even have.
it doesn't heave up like this, explodes the blades, and just run it over, huh? No, none of that. Okay, so I'm just saying is, you know,
Wheelie mode.
If that maneuvering needs an encoder, you know, that might be okay. But you know, if you've got RTK working, you still want an encoder for speed control, I believe.
No, you
Might be able to do that open loop enough, you know.
Maybe that's the biggest thing is, like Ray said, the speed control and the consequent resolution of your angular control.
Yeah.
yeah.
Okay, thanks for that.
Yeah.
Guidance, guys.
I mean, how much work have you got entailed on this current solution?
Not a lot. A bit of software and you know, it's easy enough to add one add a wire to the harness, and then I'd need a new connector probably. So what do you think the possibilities are for a connector? What do you think the connector solution would look like on the back end of the motor?
Okay, like because it was easy, all right. Otherwise, the original connection to this encoder is 2.54 millimeter female DuPont style. Okay. So I didn't cut, I just separated them, and I just popped off the 6-pin header and put a 4-pin header and a 2-pin header. The 4-pin header, I think, is sufficient because it's easy to plug into almost any board. The power, I might go with a battery solution. Okay. I don't think you need any heavier wire. Okay. But it would be nice to have, I'm not sure.
I'm sorry, I wasn't clear in my question.
Yeah.
I was really thinking about if I throw away the current motor, which has that 6-pin Molex Minifit Junior connector on it, and all I get out with this encoder is a 6-pin DuPont style single row connector plus 2 power wires. I have to replace them with something. So maybe I have a 2-pin Minifit Junior and a 4-pin or a 6-pin. I don't know. I'm thinking about what.
Well, let me show you. This is what you get.
Yeah.
That's 6 pins. These two on the end here are power.
Yeah.
Let me get the right two. These two on the end are power for the motor. These 4 are encoder related.
Oh.
Okay,
Why do
so
you have 4 wires off a 2-channel encoder?
they give you power and ground.
Oh, they do.
Yeah. So that way you can isolate it from, completely from your motor. You don't have to use the motor ground or anything.
So you're running motor power for that size motor through those little bitty pins?
These wires, all right, I'll show you how big they are.
Yeah,
Like that.
like maybe 18 gauge, 20 gauge.
And there's nothing, if you look at, if you want to do it, there's nothing from changing these 2 wires and just going over here to here and bringing out whatever you want.
So are you wiring the motor
But
power wires to that circuit board?
how many amps did you guys say that these motors pull when they're under stress?
It's about a little over 300 milliamps.
Well, that's
So-
when it's idle. I think I measured about an amp or 2 when I was just putting my hand on the wheel and trying to restrict it as much as I could.
For an amp
Oh.
or 2, I still think these would probably be okay. If you were saying 4 or 5 amps, then I might want to beef them up. But
Does that board that you buy from Amazon, does it have like a place where you solder the motor wires onto that board so that they then get brought out on that connector?
okay, if you look at this uses, by the way, this is the size of the wire that comes out of the motor.
Yeah, it's small. Not very
Okay, that's it. That's what's coming out of the motor. Let's go back to this other guy. Oh, here he is. So if we look red to red, I'm just gonna say, I don't know if you can see
It's
that.
about the same. Yeah, maybe a little skinny. Yeah.
I don't think you need. I don't think you need to do much more. Okay. Now, if this guy had been a big, hefty 16-aught wire, and I'd be concerned, but they look like they're the same thing.
Yeah. Okay.
Okay. Now, the way this was made, because on a 775 form factor motor, you have the normal thing is you have, just like you do on the polo loop motors, there's two metal pieces that come up and there's no wire on them.
Little tangs. Yeah.
Yeah, and those would be put into these slots and soldered.
Okay.
So on mine, I just stuck the wire in there and soldered it to that slot.
Oh. Well, thanks.
So, I mean, I think this is adequate, especially looking at this.
Yeah, they seemed awfully light gauge. I don't know what gauge it is. Maybe 18.
I know, yeah,
Yeah.
probably. I wouldn't be surprised if they're 20 or 22.
Oh, really?
It's hard to tell with the plastic, you know what I mean? You have to strip it off and take a look, but and do counting. But they're not significantly different, I don't think. Anyway, I think this is a viable solution. It seems to be high quality encoding, and it costs $16. So
Well, thanks, Doug.
yeah, I mean, at this point, if I needed more than two, I would just keep converting them, because without the encoder, I don't have much use for it. You know what I mean? Even if I'm not using the encoder actively for positioning, I'm still using it for speed, other stuff. Like, like Ray mentioned,
Like angular position,
angular
rotating.
Yeah. And anyway, so that I promised last week that I would go ahead and do this, and sure enough, it worked out well, and I'm glad I did say that, because it forced me to do it.
Yeah, I don't know how long the wheels are going to last. I mean, they're the plastic around I'm not certain what you call that. The slits in the shaft, it's just kind of a friction fit with the wheel, and it's kind of a rubbery material. So hopefully that's not going to be the weak point, and the thing's going to strip out in a week or something. Or if it gets stuck and,
They look like good wheels.
yeah.
But I have to admit, I was a little surprised at how many extra wheels they had.
Oh,
like, for every mower, they had probably 10 or 15 wheels. And I was like, whoa, maybe that is kind of important.
Maybe that is the weak point, huh?
Yeah. But just looking at them, I didn't see anything right off that I thought would be something that I would worry about.
Oh yeah, it's I think they call them splines. It's like a 6-splined shaft, and the wheel is made to fit, very tightly over those. And I thought, anywhere.
I haven't done it, but I believe when it pops on, isn't this little area here on the end, doesn't that kind of like pop up and hold it on?
Yeah, you push it in and it snaps around that.
Yeah.
Yeah. I noticed on yours, mine did the same thing. That little button or knob, it doesn't have to be. I mean, it's rotating at a slow rate of speed, but it's a little off center with the rest of the shaft. It's like,
yeah.
Not quite, on center.
Yeah.
Like, okay.
Not perfectly concentric.
Yeah.
Yeah. Well, that just means bearing wear. Now the question is which bearing.
Oh yeah, there is. I took that apart. There is there's a ball bearing in there and an O-ring seal.
In the black plastic piece?
Yep.
So it's got beyond the output. That's good.
Yeah. So it's not a real you don't have a real overhung load, there is a bearing pretty close to where that wheel connects to it.
Pops in.
So, yeah. So, which is good and bad. I mean, it's, it probably works great for them. You push the two little tabs, you pop the motor out. If you need to replace it, it's pretty quick. But it's probably, if you want to keep that little plastic extension, you probably have to make a custom piece to, maybe to fit with Go Build a channel or something.
Mhm.
So it's got to be the right thickness, and those little screws have to attach to something, whether it be another piece of plastic, or maybe you may use a machine screw and thread an aluminum piece that holds it all together. But even aluminum isn't that strong, so especially for screws that size, it's not going to have a lot of strength to it. So, but I'm gonna get some.
When I start seeing them running on the Robo Columbus, then we'll learn a lot. We'll learn real quick. That wasn't so cool, but my current model from last year had a Pololu 37 millimeter motors, and they were on the light side. I was limited to the type of wheels I could use on it because they didn't scuff well. If you're like in centipede grass, now it's true that there's nothing like that out at Steve's house, but if you were in a grass lawn and you have to scuff, they just didn't have enough oofy to go. So I'd be interested this year maybe to beef up to, I think they were 12 volt motors. Beefing up to 24 volt motors might make a whole big pile of difference. Mm-hmm. Or maybe I put 4 of these things out there. Who knows? We'll see. Yeah, I wish I was in Mike's envious position of already having a platform that he had confidence in. So I'm not there yet.
Yeah, those my cheap black plastic wheels, I think, are about the right width. They're a good diameter. They're less than $4 each, so yeah. Couldn't beat that. I think.
Well, these look like they do okay too. The ones from the Robo.
Yeah.
I'm thinking of seeing especially if I use their motors. They're just, if you can figure out how to make the mounting pop piece.
Yeah.
I don't know. If you look at it, Ray, on the mower, is the mounting piece plastic.
Mm-hmm.
So there's another plastic piece that this pops this plastic piece in.
Oh, there is, huh?
I mean, is there? Do you know?
Oh, I don't know. I don't have the motor. I just have the motors, not the body.
Oh, okay. I'll have to
buy a mower.
If the body has, if this pops into a plastic piece that's mounted onto the mower chassis, then maybe you can just undo a couple of rivets or on screws or whatever they got it attached to and just repurpose it.
Yeah, I don't have the body though, so
yeah.
What is it like all molded in one piece, Paul?
Yeah.
Is that one of the RoboMos that was available from them?
Yeah, 2 of them.
Oh, okay.
Twins.
See. So you're asking about how does it attach on the
So like if you popped off,
right?
If you popped off those 2 tabs and pulled off the wheel, what do you see?
Well, okay, so the wheel comes with the motor. So these 2 tabs pull off the wheel and motor.
Yeah.
The wheel is secured by this white plastic.
Oh yeah, okay. Squeeze that white thing and pull it off.
Okay, I gotta get a tool, I think, because it's kind of stiff. You know, let me get a E-clip pliers.
And by the way, if you wanted to repurpose that Molex connector, you know, you could, if it has 6 positions, you could just change the.
Yeah, use those.
Yeah. Here we go. Let me see if I can get that off live, maybe.
You need to do those, you know, pinching force exercises, you know, that hand grip things. You know.
Yeah. There we go.
Yeah.
So that just has a couple of tabs.
Yeah.
Right.
That
This is
poke
fine.
Yeah.
through to this side. Is that what you wanted to look at?
No, I wanted to
Oh
look at.
no, how the motor attaches to the body.
Oh, so, okay. So, so this thing just pulls off
Yeah.
like so.
Okay. Oh yeah, you have to squeeze it, I guess, or pull the tabs. Yeah.
Okay. So now what does that fit in? What did those little tabs fit into? It
So
looks like another plastic piece.
yeah, well, no, this the shaft here. Let's see if I can. So this is a molded plastic piece that's part of the body, and it has some clips. You can kind of see a tab there.
Yeah. Okay.
Trying to
So
get it.
just a tube. Yeah.
It's really just a tube with, sorry,
Some raised pieces on it to catch those 2 tabs, maybe.
yeah.
Yeah. If you go back down the shaft, what is the plastic piece attached to?
To the frame, I think he said, right?
Yeah, it's attached to the frame.
Yeah.
So this is part of the frame,
Oh.
and I think it's plastic, and so this tube comes out of the frame, and the tube goes all the way through, but it's really molded to the frame, or in some way like
Part of
a
it,
part
yeah.
of the frame.
Yeah.
Mm-hmm. So maybe if you just modeled that in part.
Yeah.
Yeah, I think if you just model this in piece, then you could get the clips to clip right onto it.
Yeah. I thought about using an aluminum tube and just cut out 2 slits for the 2 hooks on the 2 tabs so that it you know, it could catch that.
Yeah, it is. You got to watch out as you put it in. Oh yeah, this little, there's a slot right here.
Yeah.
In
A
slot in this sticking out bit, and that has to go over this ridge.
Yep.
So, and that's what locates it in the correct orientation, so that then as you push it on, the clips will pop on.
Yep. Grab something back there.
Yeah, it just grabs these ridges that are sticking up out of the tube.
Yep.
Oh, that might be modeled. Like I say, you might be able to make one of those, Ray.
Pretty easy to.
Yeah, to 3D print it maybe.
Yeah.
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 Or I like the idea of if you had a aluminum tube, if you could make that. I mean, didn't look like if it's just a notch, and you might have to put a ring around the tube to give it higher dimension, a bigger dimension.
Mm-hmm.
So it would have something to grab behind.
Yeah.
Oh, that might be doable.
Yeah, I thought either that or mill a slit so the hooks can catch the slit.
Catch, yeah.
Yeah, something like that. Yeah, like I said, the first set of hose clamps did not. The motors were twisting in the little bracket that I had. It's like, okay, well, that's not going to work. So I put a second set of hose clamps on it, and that kind of restricted it from twisting.
Yeah.
So, but it was, just kind of a quick and dirty test. Did it have enough torque? And it seems like it's got plenty of torque to even go up a small incline that I tested. So.
Oh, and then there's the other possibility: just strip down the frame. You don't have one though, Ray, right?
No, I don't.
Yeah, I could possibly strip down the frame and make it just the differential drive type mower. I mean, robot. Yeah. Have to see.
Yep. Anyway. Oh, I had some things. I don't know if anybody's seen this. Apparently, ST. Oh, am I cutting anybody off? No. Okay. ST had the latest and greatest. They refer to it as a 3D time of flight LiDAR. And instead of, like an 8x8, it's like, I don't know, 50 or 60 in each direction. And it's in an array, and it looks very similar to the other ones. Let's see if I can show that. A tab. There's a dash tab. That one. Share it. And I don't see anything. Oh, there it goes. Okay. I don't know. Tab. If I go on the tab. State I'm modeling. Yeah, it's this one. Come on. Let me see if you can see that. Well, it doesn't show it. I guess I got to get out and get back in. Anyway, let's see if I guess I got to click on it a different way. Like preview.
Click on the link below it. See if that one will work.
Oh, okay. Yeah, I think I see what I have to do. I have to.
Well, all of these multi-zone TOFs, they're getting to the point where I don't think, unless I can get some good AI help on how to program those things, I'm not sure I know how to apply them. I can think about it, but I'm not sure yet how I want to be able to apply. So let's say I do have a big cloud.
Yeah, well, there we go. Okay.
Big cloud. What do I do with it all? How do I process all of this information I'm going to get?
Yeah, I don't know. I think they make this fits on like one of the Nucleo boards.
Yeah,
it's a 54 by 42, array of sensors.
Wow.
So yeah, I think you'd. Yeah, you probably need something to help you with that, or if they already have an application written for it. But don't know how much it costs. It's small. They're saying 5 centimeters to 8.8 meters. Okay, I don't see anything right off the bat about whether it works outside or not.
Yeah, I see something that I think is telling, and that's if you read the last sentence there, it's 55 degrees by 42 degrees field of vision, which can be reduced by software.
Yeah.
Which means that they probably don't expect you to use the whole array.
Yeah, maybe not. Maybe you could look
I
at
don't know.
like lines or
Yeah.
different areas. Yeah.
Like Kareem, he was saying he was trying to detect the ground. Like, where is the ground? So
Yeah.
those sensors are good for that because they can see down and.
Yeah, I could see that.
Like,
If I remember correctly, there was a note in there saying it works up to 750 lux. And I think Sunny is 15 to 60K lux.
Yeah, much higher. Yeah.
So basically it's an indoor only sensor.
Yeah. Yeah.
Uh-huh.
Yeah.
And that makes sense, right? Because it's got to flood a whole scene with an ultraviolet, with an infrared flash.
Yeah.
And it's not going to compete with the sun in that respect.
No. Yeah. Anyway, I thought it was kind of neat. It's like these things are, it's like Samsung phones. I don't know what they're up to now, 26 or something, So the last one that I heard about was the VL53L8CX. Now they have the 9CX, so, or maybe like, the iPhones, what are they up to now? Is it 16 or 14? I don't know. I don't have an iPhone, so.
All I can say is that and it's interesting how the range has gotten longer and longer on these VL chips.
Yep.
53L chips.
Yeah.
Every generation is looking out further than the previous one.
Yeah. Oh, and the other kind of out there thing that I heard was I guess they're starting to look at geomagnetic mapping because of situations like GPS RTK doesn't work good in buildings or under heavy vegetation, or you can jam it in military situations, and so I don't know how they're going to do it. I wondered if anybody else had seen any articles about that. But apparently there's a way to map it, and somehow it's unique. I don't know how it's unique, but they were thinking of that as a replacement for RTK GPS. And I thought, wow, that's out there.
Everywhere or just inside?
Apparently anywhere. Yeah. So, and it's just looking at the magnetic field of the Earth, which is, pretty hard to jam.
Yeah, in my mind, when you say that, I think of those QL 50, 58, 50 something magnetometers, and I say those things are a pain in the butt to use. I can imagine what this other one would be.
Yeah, I don't know.
Probably could tell you were on Earth or something like that.
Oh yeah. You're on Earth and you're pointing somewhere near north.
Yeah. Kind of.
Yeah. Anyway, yeah. So I thought that was kind of interesting. It's like, wow. So who knows what's going to happen with that?
Well, who knows? I would have never believed we would have been here 10 years ago. We got so many cool toys, we can't keep up. I mean, 10 years ago, if you had a GPS that was actually had 2 constellations on it, it was like, whoa, dang. Most of them were truly only GPS. And now you can, and everything else.
4 or 5 systems, yeah.
Or even the RTK prices, they're like, boo. Or even LiDAR prices have gone.
Mm-hmm.
Speaking of cool toys, Speaking of cool toys, thank you, Doug, for sending me that link to the Digi-Key thing that's going down in the middle of August.
Uh-huh.
I think it was you, right?
Yeah. Well,
It's got two little balanced robots on it that you can get from Digi-Key, and they're having a whole class workshop thing going based on, buy the thing, show up, and away you go. And that's cool. We're gonna those are very small kinds of things, but they look to be cool. And I think I'm gonna get one of each, and I'll play with them and go through the class. It looks like it'd be fun.
Well,
And I wouldn't see it other than you.
and and tell us how they do too.
I will do that.
Yeah.
I will do that. And then just based on the M5 stack and ESP32, so they're not that big a deal. And I don't have a link. I do not have a link handy, or I'd give it to you right now. I just don't have one.
Yeah.
Pretty cool.
Mm-hmm.
And I didn't get to say it this week, but I wanted to make sure I said thank you to you.
You're welcome.
Okay. I'm done now, I think. Unless somebody wants to ask me another question, and then I'll get to talking again. And then, we all know how that ends up. So.
Oh, Pat's not on. He did, last week he told me, why did I like ASA and ABS over PET-G? And I think here in Texas, PET-G has some issues with temperature. It's better than PLA, but it's not near ABS if you took a PET-G robot, put it in your car and forgot about it on a Texas afternoon in the summer, it would be almost as bad as PLA, so up there in Canada where it never gets above, 50 degrees, I guess, PET-G would be fine. I've been but because of his suggestion, I actually got a roll of this stuff and been playing with it, and it does prints pretty good. So, but it's a little more expensive than PLA, which is what I tend to use for prototyping. For an old retired fart, time is of not the essence. It's just put it on the printer and let it rip. So, doing it 2 or 3 times is not a problem. And so I usually do PLA until I got the design where it looks like it's going to be a final job, and then I go ahead and do it in one of the more expensive, or
higher
heat temperature. That's kind of one of my top priorities. I made the mistake of making a robot. I think it was one of my early rovers, and making all the prototypes in PLA, and I got lazy and said, I'll just leave it there. It looks good. Well, I got outside and just driving someplace with it in the car. When I got it back, everything was so I'm not going there. Yeah.
Yeah, I just put a link for the PLA and the DG that I use.
Yeah.
What about ASA?
From
Anybody
Voxel
using
PLA? It's pretty cheap and it works really well.
Yep. Yeah, I think I just bought some off of, I want to say Micro Center for $10 a kilo. I mean, that's pretty close. I don't know if it was a sale or what, but it I picked up black and white. You always can't have enough black and white.
Yep. Is ASA that popular, or is that?
It's kind of
it's becoming more and more popular.
Yeah.
If
you think
finding it as a valuable replacement for ABS,
right? It doesn't have. Well, okay. You almost have to use the same type of printer for both, but ASA is more forgiving than ABS. Otherwise, if you're doing some really fancy thing in ABS, it's not unlikely for it to crack. You can get away a lot of times with those in ASA without it cracking.
yeah, The new kid on the block is PCTG.
Yeah, and it's expensive in this realm of things. So like PLA, $10, ABS, $12 or $13, ASA, $20 to $24.
Ooh.
So, you know, when I'm doing stuff for my daughter's business, I usually use ABS because cost is important. But when I'm doing it for my own personal hobbies where cost isn't, I mean, it's like the encoder thing, you know, $15. You know, that's below what I eat sometimes. So it's like, okay, if I skipped a meal, I bought this thing. You know, the people ask,
But you'd be hungry.
And you get old enough and into some stuff, and you don't even know you skipped a meal. So there you go.
right, hey, yeah, you're right, Harold, you know, like just before the meeting, I was sitting there, what did I eat today? You know, when you get on Ozempic, for example, all that kind of fades away. What food? Do you need it?
And Doug, just because you don't remember what you had for breakfast, don't mean you didn't have breakfast.
Yeah, that's right.
Harold's got smoke going across his screen.
I've got incense. I'm like all being zen and hippie-ized with my.
Oh,
One of the things I do is Renaissance Fair. They got some folks in there that's been making incense forever and ever and ever and ever. You go in and get like 100 sticks for $25 or something. And so my company the last couple of years has provided us a day at the fair at the Red Fest. And so I go in down there and I'll get them. I got 150 sticks over here. So I'm like getting all hippie eyes up with the jasmine and the sage and the, all that, getting my chakras right, or my whatever the other kind of Gaia thing, one with the earth. I don't know. I
you
like
need to put your psychedelic T-shirt with a peace sign on it.
I do have
Tie-dye.
tie-dye. I do have my tie-dye lab coat. I think it's in the wash right now. And I want to make me a smock. I finally found a pure white smock for woodworking and that kind of stuff with pockets in the back and all this other stuff you'd want. And I think I'm going to grab the wife here sometime in the next month or two, and we're going to tie-dye those up too on the thing. 'Cause I don't know if you've ever done a tie-dye, it's a mess. It's a big old mess, and that's an understatement. But there's some cool things you can do if you get a little creative and you choose some wacky colors. And then the biggest thing for me is now I have something no one else has. You know.
Well, Harold, why do you wash it if it's tie-dyed? You can't tell if it was stained or not.
I don't wash it. The wife does because she gets all freaked out. Me, I don't care.
Yeah.
Okay. On that note,
Yeah, not caring.
anything else?
Whatever, yeah.
Anything else robotic, 3D, electronic? What should we call it a night?
Sounds like a night.
Call it.
Sounds like a night.
All right. Good night, guys.
All right,
Good
Paul. We'll
talking
see
to
you. We'll see you
next
tomorrow.
time.
Yep.
Yep.